Good afternoon. We are here today at Chabot College. Jim Baum is going to help me put the dyno through its paces today. And what we want to start off with first is to explain one of the most critical parts of the dyno, and that is getting our torque converters ready. It's necessary to take a piece of crocus cloth or some sandpaper, and you want to prepare your hubs by sanding off the paint and checking for any burrs. Then the next step that you'll do is you want to put a little bit of lube on each one of the hubs, and usually in your case you're going to find in the bottom of your transmission pan you're going to find a little bit of ATF, and that's really about all the oil that you really need to put on there. That'll help the pilot bushing spin easy. The next thing that you do is you are going to select the proper pilot bushing. Each pilot bushing has two different bushings stamped on them, and in your owner's manual you'll find the proper pilot bushing selection. These are three pretty typical pilot torque converters. The next thing that we want to do is we want to prepare our spider drive. The spider drive is what we use in the place of a flex plate. This allows us to go to several different configurations of torque converters. Those torque converters can either have a 4-arm, such as this Ford, or you can have a 3-arm, such as General Motors, or you can have a 2-arm to 4-arm on imports and on Chryslers. As you can see, this is set up for a 3-arm configuration. We're going to set this up today. We're going to run a Ford, so we're going to set it up for a Ford. Jim's going to go ahead and get that ready. Now on a Ford, you do have to use what's called studs, because the most important thing on setting up your spider drive is that the arms have to be straight across. So in that case, we're going to be using the studs. On General Motors front-wheel drives, they'll be using this 1/2-inch bushing. This will allow the arms so that the arms will be straight. On some of the Chryslers, you will have to use a small bushing between the arm and the torque converter so that you get the proper space. Okay. Be sure that the studs are tight, because if those aren't down all the way evenly, it will cause vibration in the torque converter. Now we have to be able to lift the transmission onto the transmission dyno, and we have both front-wheel drive and rear-wheel drive transmissions. We supply you with a 6-foot sling. Simply slide the strap through the hole, place the front of the strap around the front of the bell housing, slide the knot to where it's going to be right in the center. Then you slide the rear loop around the tail housing. Use your hoist and you'll pick it straight up. The lifting tongs allow us to pick up front-wheel drive transmissions easily. The weight of the transmission causes the tongs to squeeze, holding the transmission firmly in place, and the chain keeps it from tipping backward out of the way. Next, we have to be able to secure the transmission to the master plate. On this machine, there is only one master plate. These are our universal arms, and as you can see, there are several holes that you can move these arms to wherever you need to move them in order to hold the transmission. I like to start off with the arms already attached to the master plate. This makes mounting the transmission so much easier. Now, every transmission has a bell housing, and the holes are either going to be a very large hole or a very small hole. Now, on your arms, you have two different sizes of threads, so that it'll take two different sizes of bolt. You want to use the largest bolt that you can through the bell housing. The next thing we want to do is mount our transmission. It helps if you pre-align the transmission prior to mounting your bolts and arms. After we have the transmission mounted, we're going to remove the lifting tongs. Now we're going to prepare the transmission for the plumbing. We want to remove the dipstick tube so that we can fill the transmission. All right, as you can see, we need to line up our motor shaft with the pump shaft. This is the second most critical thing on the whole machine. The first one, of course, was getting your spider drive arms perfectly level. This one, we want to make sure that the pump shaft is in alignment with the motor shaft. Now, one of the things that we have with the General Motors and some of the new front-wheel drive Fords is that this shaft will move around all on its own. We'll use a small rubber black O-ring to center the pump shaft. Put the target on the pump shaft. Now Jim will align the tool. Looks good. Don't forget to remove the rubber O-ring with a small pick and remove your target. Then we're going to show you how to align it up by using the alignment tool. Remove the target. Don't forget to remove the small rubber O-ring so it doesn't end up in the transmission filter. Remove the laser. Now Jim's going to crank the motor all the way in with the motor crank, and we're going to use the manual alignment tool to do the same job. I suggest using both methods to check your work. Now we're going to back the motor out. And install our torque converter. Now we're going to stab the torque converter. That's all there is to it. Next, we'll attach the spider drive. And we'll crank the unit forward. Now on the spider arms, you want them to be pulling. When you mount your spider drive onto your torque converter, leave it loose on the hub so that you can slide it forward so the pilot bushing will go over the torque converter hub easily. Then you want to make sure that all of your arms pull the torque converter around instead of pushing it. It will help take some of the low RPM vibration out of the machine. Now Jim's going to go ahead and fasten our torque converter down, our spider arms to our torque converter. Now the next step, we're going to go ahead and move the motor forward all the way into its forward position. Once it bottoms out, then we will tighten up the Allen screws on the torque converter spider drive itself. Then you want to spin the torque converter and make sure that it rolls easily. And now Jim will back the motor off just a little. Good. See how easily that spins? If it binds on the top and then it's loose on the bottom, then you know you have your alignment is improper. Now we have to be able to attach the load cells to the transmission. On a rear-wheel drive, we'll be using a axle that looks like this. If you'll notice, it does have U-joints in it, so we're going to be able to get the same kind of a feel as if it were in a rear-wheel drive car. Now, if you'll notice, there's two different yokes on this. One end's a 350, the other end's a 400. So if you're testing a 400 style transmission, you would put this into the transmission, this would go into your chucks. If it's a 350, you just simply turn it around. So this will fit more than one transmission. If you're doing front-wheel drive, you'll need to use the CV out of the car. This is our speed control for the rear load cell. It helps move the load cell in. All you do is turn the power on, put it in the run position, either forward or reverse. This controls your speed. Next, what we want to do is mount our CV axle into the transmission. You have both a front and a rear axle that you need to mount. So it's to slide this directly right into the transmission. Next, Jim will use the T-handle to tighten the chuck up. Now, we use soft jaws on our chucks so that the material that we're holding the CV with is softer than the steel that's in either our rear-wheel drive axle or our front-wheel drive axle. This also acts as a safety device, so if the transmission would lock up, it will break loose. Be sure that you tighten down your ratchet handles so that the load cell will not swing to the left or to the right, so it's stationary. Also, there's a T-handle underneath the machine that you need to tighten at the same time. Next, we're going to take the safety shield, drop it over the transmission. Be sure that you put your locking pin back in, so if the axle would break loose or the U-joint would break, it will prevent the shield from flying up. Jim's tightening up the front axle, and on the CV, it mounts exactly the same way that the rear CV axle does. There are certain circumstances because of the fact that the axle is so close to the motor that you may have to just give a little bit of a camber to the front load cell. Again, make sure that you tighten up all three of the chuck position bolts. Jim is now finishing up installing the plumbing. You want to take out all of the plugs and all of the pressure point outlets, the cooler line fittings, remove all the brass, and replace that with the given quick disconnects. Next, we want to hook up all of our pressure points, pressure port A and B, which correlate to the pressure box A and B line, which also correlate to the gauges on the control panel itself. This one's A, this one's A, and this one is B. Now Jim's going to hook up our cooler lines. Now on your cooler lines, you want to make sure that your flow is coming in to the filter first, coming out of the top of the flow meter back to the transmission. If you make a mistake, what you'll see is bubbles in the top of the cooler flow meter itself. If you see that, simply turn everything off and switch your lines around. The next thing that we have to do is hook up our electronics. This happens to be a computerized transmission, so therefore we'll have to pick the right cable so that it can communicate back with our transmission stand. Then we'll hook up this to our stand. Now there are other cables that you can purchase for monitoring speed control and monitoring Pringle switches. The last thing that we do before we run the transmission is to fill it with fluid. We have 3 filters on the machine. One filter is on the fill tube, one filter is on the drain tube, and the other filter is a direct line in the cooler lines. Now this allows us to filter the fluid efficiently. All you do is simply turn the dial to fill and to drain to drain. Now I'm going to show you how to use the control panel. Simply turn on your computer. When the G-TEC screen comes up, click on the MD section. You can see various settings across the top. The first one is for calibrating all of your sensors that are on the machine, which is already done for you in the factory. The second one is settings. What this does is it allows you to see different settings on the machine. The next one is you can hide your gauges. These are your gauges across the bottom. The next one is to view data, where you can actually view the data that we're recording. The next one is for start recording and start test. This is an AX4N that we're going to be running, so simply find it in the drop-down menu, click, and as you can see, the AX4N has come across the top. We have park, reverse, neutral, so that we can do each one of the tests in those areas. To increase, we're going to start off by increasing our RPM so that we can fill up our torque converter. And as you slide your bar across, you can see that the RPM is changing. It will not engage until we let go. We want to go ahead and fill our torque converter. First thing we'll do is we'll put it in park and continue to fill the torque converter. After the torque converter is filled, then we'll go ahead and put it into reverse. And we'll check our reverse. And as you can see, our pressure gauges for reverse. Now we can actually shift while the transmission is moving. And we'll start that up. What we're going to do, I'm going to explain this because it's a little noisy. What we're going to do is we are going to go to neutral, then we're going to shift into 1, 2, 3. We're going to apply our TCC for lockup, then we'll go into 4, then we'll reverse as we go down. What you'll see is you're going to see these lights coming on, which are going to tell you which solenoid is engaged and which ones are not. All right, next we're going to go to engage the first solenoid. As you can see where the arrow or the cursor is, we are in solenoid 2. You can see our pressure gauges. Next we'll go to 3. And we shifted to second. This is our 1-2 shift. As you can see, none of the solenoids are engaged. The 2-3 shift, solenoid 1, solenoid 3 is engaged. We're also monitoring mainline pressure. We're going to apply TCC. And fourth, and increase our RPM. We're going to lower your RPM just like you're in a vehicle. Back to 3. Take off lockup. Back to second. And back to first. The colors correspond to pressures 1 and 2. There are many variations of the test that you can do. You can do a park test first, then your reverse test, then your drive test. And what we showed you is how to do each solenoid in each shift individually. But the machine will also do an auto test. You simply click onto this spot right here, and the machine will do a complete auto test. All you do is watch the machine as it shifts it through first, second, third, fourth, and then back again and applies lockup, and then gives you a printout on whether or not the unit passed or failed.